think I might just carry this around. So I'm Martin Bunch. I come from the Big Slope, Big Slope holding against me, at York University, where I'm a professor in the Faculty of Environmental Studies. So I'm a professional nerd. So what I'm going to talk about today is going to be sort of academic, sort of the conceptual end of things, and the idea is that other presenters throughout these 2 days will have sort of practical on-the-ground examples, and hopefully we can make the connection between some of these ideas in theory and observation with some of the case studies that have been presented. Now, how do I change the thing? Come up. Okay, so a couple of concepts. I'm supposed to be talking about scales of interest, but scale is tied to a bunch of other things. So we've got to sort of connect the pieces in order to understand the concept of scale. And so we're dealing with coupled human and natural systems. That's where I come from. My area of work is environmental management and complexity and ecosystem approaches to health, which deal with these coupled human and natural systems, relationships. And that's complex, and that's more than just complicated, right? It's the way things work together and organize and maintain organization. But that organization happens at different levels. That's scale. That organization is also based on how you perceive what is of interest in a situation, and that's type. And things tend to organize themselves in terms of hierarchies. Some people call them holarchies. And they're dynamic in a particular expression that these days is known as scale. And so these might be some, for those of you who study this kind of stuff, those might be terms you encounter. For others, they might be new. So if I go off my rocker and you just can't understand a word that I use, because I tend to sometimes fall into jargon, I'll try not to do that. Please let me know. Just wave at me and say, what does that mean? And I welcome those kinds of interruptions. So first, I'm not going to talk about what is complexity, but hopefully we can start from the point of recognition that the world is a complex place, and that means more than just complicated. It's a set of relationships that maintain themselves. You can have sort of self-organizing and evolving kinds of sets of relationships, and that's a complex kind of thing. Things that can maintain their organization and then reach a tipping point and then suddenly reorganize in a different way. That's one of those kinds of characteristics. But one of the key kinds of things that we need to understand is that when we look at the world, we use these kinds of organizational concepts in our heads to sort of think about, to help us think about the way we observe things. And the way we think about that, it depends on things like what our interest in that situation is. So what are my values? What do I want? What do I perceive as a problem? What's my sense of skills? How am I trained? All of those will determine which of those relationships or components that we see in the real world we pull into the foreground and put together as the system that we are trying to define on the ground. And that I refer to as type. This is something that a guy named Tim Allen has sort of put out there as a sort of primary way to understand the nature of a system. So what is the type of system that you're looking at? And that type will actually define the scale of the system that you look at. So you identify what is the interest, you pull those things into the foreground, you see sets of interacting components and relationships, and they have a particular spatial footprint, right? And that's the scale. And so that's type and scale they're married, right? You can't have one without the other. Let me give you an example. Here we have a problem, an issue. It's a power corridor that's going to go through near where I live, southwestern Ontario. And there's different perspectives on this problem. The hydro company, power company wants to transmit power. The scale of the system that they see with respect to this power corridor is southwestern Ontario. That's their grid, right? And so they've got a spatial footprint of southwestern Ontario. The farmer who's on the line of this power corridor wants to keep pylons off his farm. His scale the system that he's interested in with respect to the power corridor is the scale of the farm, a much smaller footprint. Whereas a naturalist, somebody from an environmental NGO or something like that, is interested in protecting natural areas, so he'll have something in between the southwestern Ontario and the farmer scale. He wants to protect, wooded spaces, those kinds of things. So their system is a natural ecosystem that they want to keep from being fragmented. Municipal governments have a different scale. They're, in the municipal kind of region or the city level, yet another scale. Their interest in the power corridor is not to interfere with the city and their master planning process. And so each of these actors have a different perspective on the same problem, and each of those end up bringing to the foreground different sets of issues, different components, different relationships that manifest themselves at different spatial scales on the ground. So it's not a simple thing to say, okay, well, here's an issue and the system involved is this, and here's the spatial scale, because there are different sets of relationships that are important in the same situation, different perspectives, different actors, and those depend on things like values and interests in the situation. But things do when you can identify appropriate scales, and often by, we keep referring to participation and such things here. We can often get groups of people together and they can together define what they would agree on as an appropriate scale for things. And when we can do that, we can start to look at how those scales interact. So they tend to organize themselves in sort of nested hierarchies of things. So for example, here is an example of a forest that you can identify having different spatial scales in terms of its subsystems and its wider systems. So that's the hierarchy, right? The systems will be composed of subsystems. Those systems will have wider systems or environments, which can also be conceived of as subsystems. So this is actually a pretty simple and simplistic way of thinking about it. But you can start to sort of get a grasp of the nesting this way. But you also notice that it's not just spatial scale. It's temporal scale as well, right? So at the small scales, things have a small spatial footprint and are operated by fast processes. As you get larger, things have larger spatial footprints, and the time scale gets longer. They have slower moving processes, right? Faster processes, smaller scales are nested within longer processes and larger spaces, right? So there's that kind of nested hierarchy. And you can see that in lots of different things. Here's an example of some kind of spatial kinds of manifestations of systems. Here's an alligator bowl and a 10 meter by 10 meter kind of space. There's processes and organisms and relationships that operate within that spatial scale, right? And they operate pretty quickly, right? So the alligator keeps the hole open, and you have things like mosquitoes and insects that spend their whole life in there, and they have a little ecosystem that operates on that spatial scale. You expand out to a kilometer, and you can see different spatial processes and different patterns appearing on the landscapes to characterize that kind of landscape scale. You go to 100 kilometers, and then you get a physiographic region, like a scale at which processes on the land and the surrounding water affect the precipitation regime in that area, and you can see processes operating on a spatial scale at 100 kilometers. The same with 300 kilometers, and the same with regional bioregions. This is the scale at which nesting birds or wading birds will decide on their nesting locations within this kind of scale. And of course, the global systems. You can see these kinds of things happening in all sorts of different kinds of phenomena. This is one perspective on what's important, and then you can identify the nesting of the scales within that. But don't forget that these are also dynamic systems. Has anybody seen this figure before? Okay, so only a few. less than half. This is sort of a current expression of dynamic